Hello everyone. So let's solve next question, and the next question is fifth question in the list. So let's try to solve this. Let's read the first question. Okay, the question name is search insert position. Okay, given a sorted array of a distinct integer, remember this distinct integers and target value. Return the index if the target is found. If it is not found, then okay, if the target is found, then I have to return that index. If it is not found, return the index where it would be if there was inserted in order. Okay, you must write an algorithm with big of log and runtime complexity. So let's try to understand what problems demands us. So the problem gives us an array. Let's take the array 1 3 5 6 1 3 5 6, and we are also given a target which is 5. Okay, one second, where it is here. Okay, target equal to 5, and the very first case is like case 1. You can say it is also mentioned in the question that if k is present, if target is present, then we have to return that index 0 1 2 3. So in this case we will return this index as our answer. So case 1, I think everybody is clear. Let's take case 2. Case 2. Let's take an array of, okay, so let's take example 2, 1 3 5 6 and target equal to 2. 1 3 5 6 and target will be 2. Okay, let's do indexing 0 1 2 3. As you can see, target is not present in array, so we have to return what we have to return now. So we have to return a position where it is inserted into array so that it will remain sorted order. So like if you try to insert 2 here, first position, then the array will become like 2 1 3 5 6, which is not sorted. Okay, so let me erase this thing. If you try to insert at position 2 or position 1, then it looks like 1 2 3 5 and 6. So this is the correct position. Okay, let's take one more example, and the answer of this case 2 will be this index 1. Okay, let's take one more. This is going case 2. So let's take another example which is given in the question 1 3 5 6 1 3 5 6, and target will be 7. Okay, now as you can see, target is not present in the array. Let's do indexing 0 1 2 3. Now if target is not present, let's try to check, can I insert it into at the very first position, which is 0th index. What will be it looks like after inserting? It will be 7 1 3 5 6 inserted, but it is not sorted, so this is not acceptable. Okay, let's try to insert at position 1. So it looks like 1 7 3 5 and 6, which is also not sorted, so we will not take this. Let me erase this, and if we try to insert this here, so it looks like 1 3 then 7 then 5 then 6, again not sorted. Let's try to insert at position 3 here. So it looks like 1 3 5 7 and then 6. This is again not sorted because 7 is coming before the 6, so this is not sorted. Now let's try to insert at the very last position here. So you can assume there is an index called 4. So let's try to insert here. What will be the array now. It will be 1, 3, 5, 6 and 7. This is sorted. So the my answer will be 4. So this is my answer for this test case. Okay, so let's try to do. Again, the brute force approach is very clear. Like go to each and every element and uh, try to put the element here and see if it is if the next element is lower than that element, target element, then it will take big O of n square, or you can reduce also it to big O of n. Okay, so we have to do big O of log n. So how it will be? So let's try to analyze it. So solution is like binary search. Okay, so the very case number one is very simple. Like if the array, if the target element is present in the array, then we have to return its index. Okay, so we don't have to check. In a binary search, what we will do, like if the array is given like 1, 3, 5, 6, 1, 3, 5 and 6. Okay, now let's say target is given is 7. Okay, let's do indexing 0, 1, 2, 3, and in every binary search approach we have to pointer, like low is pointing to the index 0 and high is pointing to last index of the array. Here it is 3. Now we will calculate its mid. The mid formula will be low plus high divided by 2. In this case, low is 0 plus high is 3 and divided by 2. If we perform this thing, then we will get 1. So mid will be 1. So our mid is this. Now very first case, if my target equal to array of mid, then I'll simply return this index. Okay, is that clear? Okay, now there is only two cases. Like what if my target is greater than array of mid? Okay, this is one case, and there is one more case, that if my target is lesser than array of mid. So let me write it correctly so that you, this is array of mid. So we will already cover equality case. We left with only two cases, less than or greater than. So these two cases are just telling me where I have to search now. Like if this is not true, that means we are trying to search either left half or either right half. These two conditions are going to tell me either I move to left or either I move to right. So if my target is greater than array of mid, let's say, let's understand my target is 7. Okay, my target is 7 and array of mid, what is array of mid, is 3. As you can see, my mid will be pointing to the index 1 and the value at index 1 is 3. So my target is greater than 3. Okay, so can you think where I have to, where we have to move? Like we have to think in this way, like we have to take our values to the target. Like if I have greater 7 and my array of mid is 3, so I have to move in the right direction. Why? Because in the right direction all the elements are present, it is greater than 3, so I can find equality sign. I can find equality. There might be a 7 present in the right hand side. There is a must that there is no 7 present in the left side. Why? Because it is sorted and the left side does not contain a value which is greater than 3. So we have to move right. How we are going to move right? It will be low. I will take a low pointer to the mid plus 1. So it will be mid plus 1. Okay, let me erase this thing so that, okay, okay. Now we have left with one more case, that is target is less than array of mid. Now let's say my, okay, there is no element. Let me take one more, and let's say array is given like that: 3, 7, 8 and 9. Okay, this is array, and my low pointer is pointing to here, high pointer is pointing to here. If we calculate mid will be this. This is equality case. You can return answer. Sorry. Let me take another case so that I will explain this if condition. It is 7, not 7. Okay, we have to take target is less than greater than. Okay, so let's try to 8, make it 8 and 9, and here is 10. Okay, so my low is pointing to where, and my high is pointing to last index of the array. Now if I'm going to calculate mid, it will be pointing to here. And if you can see that my array of mid is greater than target, my target is 7, so 7 target, and array of mid will be 8, it is greater. So where do I have to move? Because I have to make array of mid to 7, I'll try to move its left side. If I'll go to left side, I'll get a element, all the elements are less than 8. So I'll go to its left side. How? High equal to mid minus 1, and I also store this index or answer equal to mid. Okay, let's suppose the 7 is not present inside the array, and there is actually not present. So if you try to find 7 in this array, okay, 7 in this range, because you shift your search space is reduced to this much. If you try to find 7, then there is no 7, so you have to return a position where you have to insert it. So this is the very greatest first greater element, which is first greater element uh, of the k, like it is the first greater than 7. Okay, I hope this much is clear. So let's code it so that you can understand better. And whenever you try to solve a binary search question, always assume that mid is going to be your answer. And according to mid, there will be only 3 cases. First, whatever you assume that it's going to be your answer, you have to validate. If that validation is incorrect, then you have left with 2 conditions, that you have to move either left or move to right. So according to that, you have to write the conditions. So let's try to implement this code. Okay. So let's create a variable called n. It's going to be store my answer. Now, sorry, length of the array. Now low 2 pointers, and high will be n minus 1. Now while low is less than or equal to high, I always calculate mid. Mid will be low plus high divided by 2. If my array of mid equal to target, then I'll just return mid. Okay, if it is not equal, then I have created 2 cases, that is array of mid is lesser than target, less than target. Now what we have to do, like arrow of mid is less than target, then I have to move, I have to search in the right half, so it will be mid plus 1, else I left with one case, so I can directly write as answer equal to mid, and now search for in the left half, it will be mid minus 1. Okay, after that I'll return answer. Okay, now answer let initialize with, and why initializing with it? Let's suppose there is no element and there is all element are less than k. Let's say this is the case. Once again, where it is, so this is the case in which all the elements in the array are less than 7, so I have to return the last, so it will be 4. In this case I'll just initializing with n. So let's try to run, and it is accepted. Let's submit this. Okay, accepted 100%. Okay, we have solved 5 questions. Now we will solve 6th and 7th, both in the another video. And thank you for watching.